Sorry about that. So here's the second part to part B here. We figured out that g prime is positive whenever the function f is positive and the graph, which is the function f, is positive for x values between negative 5 and 2. I also wanted to say we could build a little sign chart that says, hey, if you look at this graph, f, which is g prime, is equal to 0 at negative 3 and at positive 2, but it is positive at all values, and then it becomes negative all the way to 4. And over here, that would be at negative 5. That would be the starting point and the end point, negative 5 to 4. So it's positive there. So you could also visualize it using the sign chart. Second part, we're looking to see where the second derivative of g is negative. But the second derivative of g, we said, is the first derivative of f. And I want to know where f prime is negative. But I'm given the graph of f. So f prime would be the slopes. And that's going to happen for x values that are between 0. That would be negative slopes here and also negative slopes here. So it's going to be from negative 5 less than or equal to x less than or equal to negative 3, or for x's that are between 4 and 0. 0 and 4, my bad. Okay, so what does that mean? That means that I come back over here and I say g double prime, which is f single prime, is negative here, because that's where the slopes are positive. Between negative 3 and 0, it is the slopes are positive. And then it is negative between 0 all the way to 4. So negative, 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 right? So I'm looking for the common interval of these two things, right? Because I'm looking to see where is g prime positive, but g double prime negative. Well, that's going to be wherever g prime, this is positive, but this is negative, and it looks like it's going to happen at two places. So would you agree that that would happen between negative 5 and negative 3? G prime is positive, G double prime is negative. But then it's going to happen again between here, 0 and 2, negative 5 and 3. G prime is positive, G double prime is negative. So that's going to be, so on intervals for x's that are between negative 5 and negative 3, or x's that are between 0 and 2. I think this is the appropriate wording that we would need to prove that. Again, it's probably easier to see, to visualize if you use the sign chart, and we can find the place where both of these things happen. And then lastly, the function h is defined by this. Can you find h prime of 3? Well, if I'm looking for h prime, really I'm just doing a quotient rule. So anybody can do the quotient rule, right? You remember the quotient rule. Take the derivative of the top times the bottom minus take the derivative of the bottom times the top all over the bottom squared. Oh, but we want h prime at 3. So then we need to find out what g prime of 3 is, times 5 times 3, well, that's going to be 15, minus 5 times g of 3, all divided by 5 times 3 squared. Okie dokie. Oh, wait a minute. G of 3 we found in part A. G of 3 is 9. So I don't know what this is, but it's going to be times 15 minus 5 times 9, because this is this, and I know that from part A. Also, I can do the denominator and just do 15 squared, which is 225, but we'll leave it as 15 squared. And then at g prime of 3, g prime of 3. Well, g prime of 3, remember we said g prime is the same thing as f, so g prime of 3 is the same thing as f of 3. And if I look at the graph, f of 3, I believe, is negative 2. I believe 1, 2, 3, 4, 1, 2. So 1, 2, 1, 1, 2, 1. Yeah. So it looks like it's negative 2. And then I can figure this out from there, right? It turns out I can probably leave it like this and get full credit, but you can simplify it and we can get a better looking answer. So negative 75 over 225, that would be an appropriate answer. You can also divide by 5, I'm sorry, by 25 and get negative 3. That's 8, that's 9. Oh, well, that's just negative 1/3. There is our answer. How do we figure it out? Well, first, I have to remember the quotient rule because I'm taking the derivative. But in doing the quotient rule, I had to take the derivative of g, which means I have to take the do the second part of the fundamental theorem, which we had already done in part A, and we could figure that out. This is a nice example of the type of AP problem you would see. Whether it's on the AB, whether it's on the BC, this type of analysis is very common to see, as it's one of the popular problems to test. So let's practice more of this when the next time I see you, and we can kind of get more comfortable with the process.